In September 2025, a quantum AI model receives data from NASA's James Webb Telescope. Within minutes, it produces results that catch scientists completely off guard. Thousands of possible outcomes emerge, yet none resemble a typical comet. This is no longer just theoretical. AI is now predicting the behavior of an interstellar visitor. The object, known as 3I/ATLAS, is defying all expectations. As you watch, this third confirmed object from beyond our solar system speeds toward the Sun. It's moving at an astonishing 130,000 miles per hour. That's fast enough to cross the United States in just 2 minutes. But it's not just speed that has astronomers on edge. The quantum simulation has uncovered patterns that defy conventional understanding. Data signatures that traditional computers completely overlooked. Webb's instruments are tracking 3I/ATLAS daily, feeding vast amounts of data. Terabytes of information are entering systems that process reality in groundbreaking ways. What these systems uncover could revolutionize our understanding of deep space visitors. So, why does quantum AI matter in this context? Classical computers might take centuries to model interactions of interstellar materials. They analyze how dust, magnetic fields, and gases interact over millions of miles. In contrast, a quantum system can accomplish all of this in mere seconds. It runs millions of outcomes simultaneously, providing unparalleled insights. Imagine predicting every raindrop in a thunderstorm using a simple calculator. That's the limitation of classical computing with space objects. Now, picture seeing every possible path of every raindrop at once. That's the power of quantum computing. NASA's QUAIL lab has been developing these groundbreaking capabilities for years. Google's Sycamore quantum processor has shattered computational barriers. IBM quantum technology is expanding the limits of parallel processing. All of this technology is real, operational, and focused on space's deepest mysteries. When quantum AI analyzed Webb's spectroscopic data on 3I/ATLAS, it confirmed the telescope's observations and unveiled hidden details. Anomaly number 1, carbon dioxide dominance. Unlike typical comets dominated by water ice, this one shows carbon dioxide driving outgassing. And it's at levels Webb has never recorded before in any celestial object. Not from our solar system, nor from interstellar space. Every comet we've studied follows a similar pattern, but this one flips the script. The quantum simulation suggests an unprecedented 8-to-1 ratio of carbon dioxide to water. What type of object emits more carbon dioxide than water? What stellar environment could create such unconventional ice chemistry? Let's pause here. Why is carbon dioxide significant? Because comets in our solar system are typically water-rich. This one, however, is filled with CO2, as if it originated from a different chemistry set. The quantum AI simulation isn't suggesting it's alien technology. It's proposing that we need to rethink our assumptions about cosmic visitors. A comet was forged under conditions we barely understand. Imagine finding ice made of lemon juice instead of water. You wouldn't assume it was artificial. You'd wonder what kind of freezer could create that. That's exactly what we're looking at with 3I/ATLAS. The carbon dioxide signature suggests it formed around a star. This star had completely different chemistry than our Sun. Maybe a red dwarf where carbon compounds dominate. Or perhaps near a dying star pumping out carbon-rich gases. But here's what's keeping astronomers awake at night. The AI didn't stop at chemistry. It found 2 more anomalies that are even harder to explain. The carbon dioxide was just the beginning. The quantum AI kept processing, finding patterns that classical computers missed. Anomaly number 2, nickel without iron. The AI predicted a metallic signature buried in the dust cloud. Surrounding 3I/ATLAS, spectral lines show nickel absorption. But here's the catch: no iron. In every comet we've studied, nickel and iron are chemically bonded partners. They travel together through space. Finding nickel without iron is like discovering a car engine without a car. The parts don't make sense separated. Webb's infrared instruments have been scanning 3I/ATLAS for weeks. The data keeps confirming the AI's predictions. Nickel signatures are present. Iron signatures are nearly absent. This violates basic stellar chemistry. How do you get pure nickel in space? It requires incredibly specific conditions. Either this comet formed in a stellar environment unlike anything we've mapped, or something processed these metals after formation. But the AI wasn't finished. Anomaly number 3 hit even deeper. When the quantum simulation ran trajectory calculations, it predicted slight accelerations. Tiny pushes not explained by gravity alone. The same non-gravitational forces made ʻOumuamua famous back in 2017. Classical physics says comets can accelerate from gas jets. Ice sublimates, creating pressure that pushes the object. This is normal behavior. But 3I/ATLAS is accelerating in the wrong direction. Instead of the predictable push away from solar wind, it's showing lateral movement. Sideways nudges that don't match where gas should be escaping. The quantum AI ran 50,000 different jet configurations. Random gas emissions, uneven heating, rotational effects. None of them perfectly explain the acceleration pattern. Is this just exotic chemistry we don't understand yet? Gases behaving differently because of that strange carbon dioxide dominance? Or could something be steering this object? The numbers don't lie. 3I/ATLAS is moving with purpose. Hold on. A comet steering itself? That sounds like science fiction, right? But what if it's just pressure from strange gases or jets blasting unevenly from its surface? Here's the problem. Even the AI couldn't fit those jets neatly into the models. Every simulation that tried to explain the acceleration using natural gas pressure came up short. The forces are too precise. Too consistent. Think about it this way. Imagine blowing up a balloon, and suddenly, it starts moving in a perfect spiral. You'd wonder if something is controlling its path. That's what we're seeing with 3I/ATLAS. The quantum AI isn't claiming this is artificial. It's simply stating that natural explanations don't add up perfectly. There's a gap between physics predictions and the data. What do you think? Is this natural chemistry we haven't encountered before? Or could something be engineered about this object? Drop your thoughts in the comments before we show you what history has to say about mysterious visitors like this. Humanity has been watching the skies for visitors since civilization began. And every culture that looked up developed the same fear. What if something up there is watching back? The Egyptians didn't just observe meteorites. They forged iron daggers from sky metal, convinced these materials held power from the gods. Tutankhamun was buried with a blade made from space iron. They knew these objects carried something Earth didn't naturally produce. Babylonian astronomers recorded green comets as omens of war. They tracked every unusual visitor. They cataloged every strange color because they believed the sky could send warnings about the future. The Mayans called bright comets serpents of the sky, feathered creatures that brought both destruction and prophecy. Their calendars track celestial visitors with mathematical precision that rivals modern astronomy. For thousands of years, we've looked up and wondered if these sky visitors were warnings, gifts, or weapons. Every culture that survived long enough to build temples also built observatories. They were watching for something. And now, in 2025, a machine, not a priest or prophet, is telling us there's something about 3I/ATLAS that doesn't fit the natural order. The same unease our ancestors felt when they saw strange lights moving against the stars. The difference is, we have quantum computers to decode what they could only wonder about. And what those computers are finding would have terrified ancient astronomers. Because 3I/ATLAS isn't behaving like the sky serpents they feared. It's behaving like something far more precise. If a quantum AI really uncovered patterns no one else can explain, who controls that information? Right now, 3 major powers are racing to dominate quantum computing. NASA's Quail Lab processes space data for American interests. China's quantum satellites are already in orbit, collecting their own signals. Google and IBM are building quantum systems that could decode alien chemistry faster than any government lab. The first nation to crack interstellar objects doesn't just get scientific prestige. They get technological advantage that could last decades. Think about it. If 3I/ATLAS really contains materials or patterns we've never seen, whoever understands it first gets to reverse engineer those properties. New metallurgy, new propulsion physics, new ways to detect incoming objects before anyone else spots them. This isn't just about space dust. It's about who owns the first tool smart enough to predict the unknown. The quantum AI is poised to change everything. What will this mean for our understanding of the universe? The systems currently analyzing 3I/Atlas aren't sharing data across borders. NASA keeps its findings classified until they are verified. Chinese space agencies operate behind similar walls. Private companies like Google and IBM might sell access to the highest bidder. If one country's AI gets there first, do they own the secrets of alien debris? Or should this knowledge belong to everyone? The answer could determine whether humanity faces the next interstellar visitor united or scrambling. This is where it gets personal. We're not just talking about telescopes anymore. We're discussing technology that could shape who gets to explore, defend, and who gets left behind. Imagine if one country's AI figured out how to predict where the next interstellar object will appear, what it's made of, and whether it poses any threat. That's not science fiction, it's the logical next step from what's happening with 3I/Atlas. The quantum simulations running on this comet aren't just academic exercises. They're training AI systems to recognize patterns we've never seen before. Once those patterns are learned, they can be applied to anything that comes from deep space. Let's step back and look at what we actually have. CO2 instead of water. Nickel without iron. Trajectory wiggles no one can fully explain. Each anomaly alone might have a natural explanation. Together, they're painting a picture that doesn't match any comet in our databases. But here's what should really keep you awake tonight. The AI didn't return one neat answer about 3I/Atlas. It returned millions of possible explanations. And none of them looked like a comet that belongs in our neighborhood. Every simulation pathway the quantum computer explored led to the same conclusion. This object formed under conditions completely unlike our solar system. The chemistry is wrong. The physics is borderline impossible. The behavior defies prediction. Webb keeps tracking it, feeding more data into the quantum models every day. And every day, those models get more confused about what 3I/Atlas actually is. But what if the confusion isn't a bug in the system? What if it's a feature? What if 3I/Atlas isn't alone? What else is on its way? If it's a scout, what happens when the main force arrives? If it's debris from a cosmic disaster, are we seeing the first pieces of someone else's destroyed world? Is 3I/Atlas a messenger? A warning? Or just the first piece of a cosmic puzzle we were never supposed to see? The quantum AI simulations can't answer that question yet, but they're learning. Every data point from 3I/Atlas is teaching these systems to recognize what doesn't belong. And when the next interstellar visitor appears, we'll be ready to decode its secrets in real time, whether we want to or not. We may not have the final answer yet, but the fact that AI simulations are even raising these questions tells us one thing. The universe isn't done surprising us. And neither is 3I/Atlas. For thousands of years, humans looked at strange objects in the sky and created myths to explain them. Now we have quantum computers creating millions of explanations simultaneously. And somehow, that makes the mystery even deeper. 3I/Atlas will be visible for a few more months before it disappears forever into interstellar space. But the patterns it's revealed will stay in our quantum databases indefinitely, ready to match against whatever comes next. A comet from another star. A quantum AI simulation. Unexpected results that don't fit any natural explanation we understand. This mystery is still unfolding in real time. Webb keeps watching. The AI keeps learning. And 3i/Atlas keeps defying everything we thought we knew about visitors from deep space. If you want to follow this story as it develops, hit subscribe and stay curious. Because if quantum AI is right about what it found, this is only the beginning.